First things first, you made it to the last talk, so you really deserve a congratulations and really a big thank you from me. I'm David Camacho, lead data architect of the research team at Sixtera Technologies. For those who haven't heard about my company, we focus on two main businesses, cybersecurity and colocation. And my team works looking for new research and innovation in the cybersecurity business. Today I'm going to talk about high-performance pandas. In the next room, we just learned how to use pandas to automate, how to automate data analysis using pandas. But today, we're going to talk about how to make the most of this library and how to do it in the quickest way possible. Our outline today is quite simple. First of all, why should we talk about pandas performance? Then, how to really start a data frame from the scratch. After that, we're going to look how to do fast querying and manipulation on large datasets. Then, an overview of the arithmetic and statistical functions that this powerful API offers us. And finally, window and expanding, that it's basically a super important tool when you're doing daytime analysis. It will save you a lot of code and a lot of time. To start, let me tell you something about me. I have been data scientist and data architect since 2017. But before that, I have been software developer, software architect, and development team leader during more than 10 years. So I really know what's to deal with data. And data manipulation is a really, really big deal. It's really big challenge. And when I discovered pandas, once I became a data scientist, I looked at an API that looks, or it's very similar to SQL, where I was used to, but it didn't perform the way I wanted to. Why was that? Because I didn't know how to use it, and my code was like the panda over the rock, lazy and slow. But I hope today I could help you to make your pandas code behave or have a performance like the Kung Fu Panda. So let's start. Here, we're going to load a little data set. This toy data set is basically a simple list of URLs. These URLs, I'm going to download the HTML. Of course, I'm not going to do it online, so I'm going to just use files that I have preload. And let's see how should we start how should we efficiently start a data set from scratch. So when you collect data, you have many possibilities. The first one is that you can use a void dataset and then add one by one the rows using the method append. That seems pretty clear. That seems pretty obvious when you're a programmer. But the fact is, append method is not made for adding just one row. It's optimized for adding many rows. So in this case, I'm just trying to load the files. I'm not downloading from the internet, but loading the files from the disk, 10,000, that shouldn't be a huge amount of it, and it takes up to 30 seconds. So it's a lot. If just 10,000 and you're doing data analysis, imagine what should be like 1 million documents. It's too many time. But instead of that, if I just load these 10,000 domains in a Python simple structure like a dictionary, and then I use a method that is optimized called fromDict. This fromDict will give me the same result exactly in just 3 seconds, one whole order of magnitude of advantage. And as you can see here, I use the parameter orient. This parameter orient with the value index help us to understand the dictionary in a particular structure that is human readable. That means you will create your dictionary here. You will put a key with the name of the domain, that is your index, and the columns will be specified with a value of that key being a new dictionary, and this dictionary will have the key of each name of column and then the respective value. So it's easy to read, even if you have only the dictionary, but you will have the same exact result. Now, when you're continuing with your data analysis, what you will have is you have to iterate or pass calculating or extracting some features from each one of your rows. So what should that mean? It means that you actually need to create an iterator or an iteration, a loop, basically, a for in this case. So if you really need a loop, which is, it shouldn't be most of the time, use the iterRows method, because it will allow you to have the index and the row as a series, and you can manipulate it directly with an iterator. However, it's not recommended. So in this example, what we have is a search criteria where basically when I was downloading the HTML content of the domains, all of them return a successful code. However, some of them in the content of the HTML says that it was actually a 400 error. It means that it has no content at all. So what I'm looking in here is trying to find the 400 errors, and if I do it using an iterRows, my time is 23 seconds, almost 24. So again, it's a lot of time. I'm just iterating over 10,000 domains. It's too many time. Instead, if I use an apply method just to generate a true-false series, and then I use the log method to search on the data set, we can have the same response exactly in just 21 seconds. It's not a huge gain of time. However, it's because of two things. The first one is that this is not the best way you can do it, but also it is because there are many methods that could help you to make this in a cleaner way. But what you can see here is that you saved a lot of code. So it's not only time waiting for the code to run, but it's the time you waste coding. So here you have almost 5 lines of code doing a simple task. In here, you have 1 simple line of code. So it's really, again, in your time. This talk is not about, of course, only how to make the most performance of the library, but how to make you better performance and cleaner code when you're doing data analysis. Another important task is combining data sets. What does it mean? It means that it's common that you have multiple sources of data. For instance, you have, think about you're trying to create a machine learning algorithm to differentiate legitimate URLs from phishing URLs. So legitimate URLs won't come from the same source that phishing URLs. So it's common to need to combine data. The combination of data, it's also a super easy and super fast task here in Pandas. So what we're doing here is just loading 10,000 new domains and doing the same exact process. Now, the method append will allow you to just in 5 microseconds, in 5 milliseconds, you will have you will pass from 10,000, in this case filtered 9,700 rows, to 19,700 rows with 1 column. It means I could just increase my data set in just 3 seconds, basically. So I didn't have to wait for 30 seconds, 60 seconds, a lot. I'm just working with a 20,000 data set, so it's really, really small. And this method works perfectly. So what you want here is to use the method append. It belongs to the data frame object, and you just specify a new data frame with the same columns. It will work with different columns, but of course that is not the use case you want, because you will have a lot of the half of your data set full of non values. You don't want that, right? So in this case, we have 20,000 domains, and it was super fast. There is another important method, but in this case, you don't want to add data vertically. What I mean with vertically, I mean just make longer your series or your column. You want to add columns to your data. So the method concat will receive an array or a list of data sets, and it will just merge all the information. But you have to be careful, because as you can see here, only 11 milliseconds, it's the time that the task took for joining 20,000 domains information with the information of who is from these domains. It was just loaded before. Now, look at this. It is interesting. We passed from having 19,700 domains, or rows in this case, to 27,100. But also, we passed to have 7 columns. But how does it look like? So here we have the content, as we see before, but now we have 6 columns full of NaN values. It is not useful. And here, if you look at the tail, you have NaN content. I mean, there is like none of the domains that I added were a match. Is that true? No. I actually have the whois information from a lot of those domains. So what happened here? Basically, we have, think about a matrix, and the 2 corners are full of information, but 2 other corners, the opposite corners, are full of NaN, of void values. So it didn't work as we expected, right? So how to merge that? You can fix it using, of course, the append method, but even append and concat, you will have, you will call the basic method that is called merge, that belongs to the pandas package. So here, what you will have is a couple of data frames you want to add, and you will have a specific parameter called how. This how parameter will tell you, just like in SQL, how you want to merge the information. I mean, how to tell pandas to match between indexes. Now, in the inner case, with the inner value, it will check both indexes and will find the intersection. But as it is an inner operation, it means that it will return only the intersection of both matrices. So here, our three first domains are 0123movies.com, 037hd.com, and 0day.com. And as you can see, you will have all the information. But if we run the same operation, but instead of having the outer value in the how parameter, the inner value in the how parameter, and we change it by the outer value, we will have all, of course, in super high speed or super short time, we will have the same information, but look at the three first. 0123movies.com, 0123movies.org, and 0123movies.sc. But here we have NaN values. What does it mean? There were no match between the whois information and the domain content, but still it lives there. So it could be that I have a whois information from a domain that I don't have the content, or I just filter the content, and the content will be NaN. And this is because the order will just give you the whole union, and it includes the intersection of both data frames. Now, of course, when you're trying to make statistical analysis or machine learning and data analysis, you need to do your custom calculations. Even if it is statistical, of course, Pandas doesn't have every statistical function. There are so many complex of them. So to employ those, or to apply those functions or those calculations custom, again, don't iterate on Pandas. So what you want is to use an anonymous function or use a user-defined function. In this example, what we're doing is trying to calculate from the web certificates of each one of the domains, we will have the number of extensions. What is that? It's just metadata that is included on the web certificate. So in this case, I just take the certificate, load the object, and extract the number of extensions. But I did it with an iterator using just the iteritems, that is the iterator native from the series object, and I generated a list of numbers. This list of numbers represents how many extensions each certificate has. but it doesn't have an index. It is hard to tell which number belongs to which domain. So it's hard, and I took like, 3 lines of code. So from this point, that took 2 seconds to run, I need to join this with my data without indexes. It is a really hard task to do. Now, if I just do it by using the apply method with an anonymous function or a lambda function, and using the assign method, that I could create 2 things in just 1 single line of code. The first thing is that with this name, I can add a new column to the data frame. And with the apply method, I could use the exactly same expression without a loop. And I'm doing it in the vectorized operation. So again, less line of code. It's easy to maintain. It's easy to see what it's exactly doing. And it's the same time. But the difference is I don't have to pass through the hard task of joining a sort of anonymous list. It is already indexed. So I have my values here. Now, there is a more complex case. In this case, what I'm doing is trying to extract not just the extension numbers, but many features from the certificate. So if I do it using the assign, creating different columns, and I also use lambda expressions, each lambda expressions will make me to load individually the certificate object to extract one by one the values. That means that it's super slow. I don't want that. I want fast. So I create simply a method. In this method, I'm just loading one time the certificate and then returning a dictionary with all the objects I need. So in this case, I need the fingerprint, which is basically signed in HA1. HA1, sorry. The issuer and subject, which is the information of who bought the certificate, who generated the certificate, and the expiration dates of this certificate. So when I do that, it runs in, again, 2 seconds, but here's the thing. I only will have, I only will have the dictionary, and I don't want only the dictionary. Why is that? Because I don't need one single column with dictionaries. I need each one of these fields of the dictionary split in several columns. So to do so, what I use is the JSON normalize. JSON normalize is a method that belongs to the package pandas IO.json, and it will just split or flatten our dictionaries or JSON objects in different columns, key by key. But here's the thing. I mean, it has a trick. The trick is here I don't have the same indexes that I originally had with my data frame. So how can I just merge again this information? Just as easy as use the tricks we just learned. So we use the pdmerge method. We used our original certificate data frame, but we use the reset index. Reset index will just take out the original index, put it as a new column of data, and create a numerical index. And in this case, we know this index and the new numerical index here will be exactly the same in the same order. So we can just merge with the inner parameter in the parameter how, because we know it has the same length and has the same order. And at the end, the resulting data frame, I will just reset the index to the generated new column of data. So at the end, with a single line of code, I will add all my separated columns of data extracted from the certificate. So with this, we're just in almost maybe 10 seconds of running, and maybe close to 5 lines of code, we just made a full raw data extraction from a very kind of complex object, and it's super clean, it's super easy, and you didn't waste a lot of time of your data analysis. Focus on coding things that you don't really need to code. and are just utilities. Now, we want to query this data in a fast way. So there are different operators to query data, to manipulate data, and all of them has different performance. This example is just how to manipulate data. So think about it. I have domains with whois information, right? And many of this whois information is void, is full with none values. These none values, it's not useful, so I have two different options. If I consider, or if I think that it's right, I could just get rid of these values. But in some cases, I just want to imputate those values. What does it mean, imputate? Imputate means that I will give a standard or a default value when to fill a none. But this particular example has none filling with dynamic values. What I'm doing here is just fill the none values with the same name of the index, which is every time different. What I should use, or what I use here, is the add operator. So usually, people use the lock operator to look for the data, it returns a copy, and modify the copy, then replace on the original dataset the values. But you know here it's super easy, it's super plain and simple task of replacing values. So instead of using lock, you use the add operator. It will give you a slice. A slice is basically a pointer to the actual values, and if you modify the add value, you will actually modify in place your values. So it's super fast, it's way faster than lock, and in just 100 milliseconds, you could do the replacement. Also, in this example, we're doing the IAT. The IAT, it's analogous to iLock, which means you will give the coordinates of, by numbers of the position you want to fill, you want to replace. But this example is just replacing all the non-values by the same value. It took only 148 milliseconds, but if you compare that to fill NA, it could do the task in just 7 milliseconds. So when you have those cases, please try to use the optimized methods that Pandas already have instead of doing your own code. However, you know now what is the best way you can do it, and it's fast instead of doing log and doing a lot of code, because it's more code, it's more of your time, and it's more time of the run. Now, there is another important feature that Pandas has, and it's very alike to SQL. This feature is the multi-index. So for those who have already toyed with SQL and databases, you know, the indexes are a different space ordered and specifically made to help you with the task of looking for data, because it is ordered and it has a good algorithm that is less time consuming. You will find your data easy. So you have the same concept here in Pandas. Create your own indexes will generate new arrays that will allow you to easily and fast querying data. But you can also have multi-column index, and you have basically the same criteria. It means all the columns you need and you know that are commonly queried, or you want to have it in order, or will filter or group or separate maybe your data, that's the kind of columns or data you want to have as index. So you can have 2 or actually as many as you want. So here I just added 4 columns on indexes, and you will recognize them because are at the left or at the start of the table, and it will be bolded. Of course, indexes are actually columns, are series. They're in a different space, and you can have name indexes. And it's super important because it will help you then how to recognize which actual column of indexes or data you're querying. Now, of course, there is an important one. We can not talk about lock operator, but this is the thing. Lock operator it's the most common and most better known, or best known operator for querying data in Pandas. But the thing is, when you have multi-indexes, it is super verbose. It's hard to maintain, it's even hard to write, and it's hard to understand. So, for instance, if you have the log operator looking for the google.com row, as it was one single index, or yeah, I mean, if your frame has just one single column of index, you can just use the log as it was when you have a multi-index, and it will return. Let's repeat that. It will return one single line, one single row of data with all of the other indexes and your data, right? So it worked. But what happened when I have multi-index, sorry, and I want to look for a different, not just the first, but a different index? So in this case, I pass a tuple made of slice functions. In this case, I want to look for all of the domains, so I pass an slice none, and I want these domains, I want to query every domain that has a certificate with this particular fingerprint. So my slice will have these parameters, and with this, I will return every single domain with the same fingerprint in their data, in their certificate. So I could do that query, but it's really verbose. Now think about, I want to use the fourth index. I mean, how many certificates has exactly 10 extensions in their certificate. So it's super verbose, slice none, slice none, slice none, and slice. So in this, as you can see here, basically you have to pass a slice for each one of the columns you want to query. And if you have the fourth, you have to pass 4 slice functions. Okay? It's fast, it's good enough, but it's not the best. At least not when you have a big data set. So that's the query, that goes to the query method. The query method, it's super important because it uses a meta syntax. So instead of doing a verbose code for your querying, what you're doing here is a simple Python or NumPy expression meta syntax that has logical and arithmetical operators overloaded that already has your column names as it were variables, and you can already use them as series. So you have all the internals, all the functions, all the methods, and even apply methods. And as you can see here, and this is extracted from the actual Pandas documentation, after 200,000 rows, the query method will behave better than the NumPy expression. The query method will behave better using Python expressions instead of NumPy expressions. And after 100,000 rows, log method will be the same, have the same performance as query if the data frame is small. After the 100,000, query will behave fast. Okay? So it is important. And this example, it's how to query data using log operator and how to query data using the query method. So let's put the time out of here. So what we're looking at here is the same queries made using query syntax and log syntax. So I want a simple query. Everything that has a count of divs in their HTML content below more than 100 and at least 2 scripts. It seems simple if you do it with the query syntax, but it is not as hard to understand when you do it with a log, right? So it's pretty simple, it works, you can do it the same way. And even if you can see it, it says that query took even 5 milliseconds more than lock, because we're still working with a small data set. But when I want to do a more complex query, I have to pass a very verbose code. I'm trying to find out how many domains has exactly 10 extension numbers. When I use the query method, the syntax is pretty simple, pretty clear. It's completely maintainable, right? Now, finally, what happens is if I want a very complex query, I want to find out which are the domains that ends with the .com. The top level domain is a .com. And then I want the extension number of 10. And I want also the div count more than 100 and script count more than 1. If I try to do it with the log, it's super verbose code. But here, I just have it a simple, long conditional expression. It's super fast. It's super easy to understand. And a curious thing here, I use the I level 0. What does it mean? This is the mask name for the indexes. So I also have the index names even masked to query on them. And here I'm using the string or str internal object, and I'm looking at the contain. And so that means that I'm retrieving a true-false series with a regular expression. And also, I'm using an external defined variable. So I just use the add operator here, and this meta syntax will recognize the external variable. So I can use this very powerful, and even you could use query with a query with an apply. It's super useful. Now, there is another important method here that is called the eval. The eval has a particular thing. It will recognize Python meta syntax, but it doesn't have any preloaded like query. So you actually have to create your own log operation here, and it will resolve it. But it will resolve it a little faster than do it directly. However, you must be very, very careful. The eval method works just like Python eval method. So any string you will put on there, it will try to resolve it and run it. So in this case, I just have a power operation, and it will solve it. That means that using eval should be only and only for special cases, because the way the eval works will make you sensitive to code injection. So you have to be very careful. It has to be really, really in the back, really, really isolated, and try not to use it. It's important to know it, but try not to use it. Now, series and data frames offers a powerful arithmetical and statistical API. So you have operator overloading. You have all the arithmetical and all the logical operators overloaded for vectorized operations. That means that you can use one whole series and make an arithmetical operation or a logical operation just as using a variable, and it will just generate a new series of true or false values, or with the result. So if you try to divide all the values against one particular number, you can do it. Or if you have two symmetrical, that means the same indexes and the same length of series, you can operate both of them without writing a loop sentence. So it is very important because vectorized operations are super, super optimized. When you have a data frame, you need a point to start. So describe, value counts, and unique methods are the best way to start, because it will help you. Just because you have numerical values, it will give you quantiles, counts, unique values, median, and standard deviation. That will give you a statistical point of start. The value counts will give you how many values are unique and how many times it repeats across the series. And the unique method will just return the only unique values in the series. Also, you have statistical and arithmetic operations that will be useful and you don't have to code it, are vectorized and are super optimized. That are the bar, which calculates the variation of all the numbers in the series, the standard deviation, the mean, the median, which are super important in statistics. A quantile, the quantile will allow you to return any quantile you want. It's super important when you're doing your data analysis. A count, minimum, maximum, absolute value, and a consum. A consum is super important because most of people usually does the code iterating and do it in the hard way. No, you have it. You can have it. It's super fast. It's optimized. It's vectorized, and the whole thing, it just takes no parameter. So just put the dot consum, and you will have a new series. Now, also visualization is something super important. Now, Pandas offers a visualization plot just because it's Pandas. So from your data frame, with the plot method, and you have a specific method, but you really want to use the plot one, with a single parameter, you could specify, I want a line plot, a bar plot, a horizontal bar plot, a history plot, or a kernel density plot, or a pi scatter plot. So with this, basically what you can do is look at your data and know in a visual way what is it telling you, actually what is it yelling to you. And it's important, super important, because you don't need to import anything, just use one single method and that's it. You naturally fast have your data plotted. And actually, if you use the bar one, it will help you a lot because when you have many columns, it will plot one single bar for each one of the columns. If you do it by yourself using, for instance, a matplotlib, you will have to code it a little more. So here's a one line already made for you, and it saves you a lot of time. Of course, you can do a lot more with this if you know how to play with the variables and stuff. It requires a lot of more code, but the simplest things are super easy. Of course, if you're writing a paper, to LaTeX is a super useful method because you can plot your table or your data frame, and with a simple copy and paste, you could put it in your paper, because this will generate the table in LaTeX syntax. JSON normalize, we already talked about it. It's the best method you can use for flattening your JSON data or your dictionaries. To dict and from dict are super important again because it will allow you pass from or to Python dictionaries, native dictionaries, human readable. Please use the index the orient index value, because it will allow you to have a quick look at the data and it's easy to understand. And the read CSV, it's super important method because, of course, you will find a lot of information in CSV format. But the cool thing about this is that you can import that directly from a URL. You don't have to specify the zip, or if it's compressed with a different method, you can specify it. And you can specify or customize your column names, your format, your quotation, everything. So it's super powerful, and of course, it's super optimized, so you will import your data really, really fast. Now, doing the data analysis, you want to extract features, or you want to calculate some statistical data, and for that, you may want to start splitting stuff. So there are two ways people used to do things. The first one is create a new data frame, which is not really often, and put new columns on there. The other one is just to add columns to your original data set, and then you have to split it. And usually the way to split it is because people just put a prefix or a suffix to the names, indicating that it's a feature or a calculation. And then I want to, the people iterate over the list of the names of the columns and try to find the prefix. But here, Pandas already offers, again, a powerful API with this task. So with the select D types, you can select every column that has a particular type, a data type. So in this case, we return the only dates, and here we can query or filter the columns by name using a regular expression. So here I'm look for everything that has that ends in count. And finally, I could just bring or retrieve every column except something. So in this case, everything that is not an object, I have my dates, I have my numbers, but I don't have strings. So that simple task to separate or split the data that I generated from the raw data, it's super easy if I want to. But honestly, the best practice is just create a void data set and start adding using the sign method, adding the columns there. And finally, the window and expanding. Window and expanding are super important methods because here it's kind of toy example, but when you have the datetime data, it's super important. So here, my example, you take 3 rows and start summing the values. But instead of starting at 3 and just adding a 4th one and a 5th one and etc., you will always have a 3 rolling value. Which means, what I mean with rolling, I mean that as you can see here, the 3 first will be, I have 105 divs, then I add 12 more, so I have, my sum is 117, then I add a little more, my sum is 129, but in this case, I have just 32. What happens if it's summing data? It is this number, this original number, and this original number summed because it's a window of 3. It's rolling, it's moving. So here is 12, here is another 12, and here are 8 more. So at the end, I am calculating 3 rows window each time. Now the other one is the expanding. The expanding is a cumulative operation. So this cumulative operation means that instead of taking my window of 2 or 3 and leaving it always on 3, I will start with 2, which is basically the parameter I'm telling here, and from the second row, it will start summing and accumulating the sum. So in this case, it is actually doing what it should be natural to think it's doing. So 117, 129, and 133. So it will accumulate all the rows. And this is super useful, especially when you have time data, because you want to, for instance, create a 1 minute or 1 hour windows. And you can do it. I could not cover that because actually it is a whole talk about how to use datetime internals and the operations. But you can do it. If you want to, we can discuss about it outside. Well, that's it. That's all I have today. I'm sorry I couldn't cover the grouping and aggregations. We can also talk about later. And this is my social media data. You can find this exact notebook in my GitHub link. You can toy with it. The data example I use here, I actually use for creating a machine learning algorithm. And that's why I choose to use that data, because it really take me, or maybe this presentation is based on the conclusions after wasting a lot of time during the data analysis and data row extraction from that work. So that's it. Thank you very much. And you survived the last talk, so really, really thank you.